Hey guys, welcome to the channel. If you love tech and useful tips, hit subscribe. Let's jump in.
Parsing text into structured data is a fundamental task in many programming domains, from compilers and interpreters to data validation and configuration file readers. For Python developers, the Lark Parser library offers an incredibly powerful yet simple solution, allowing you to define complex grammars and process input text with remarkable ease. This tutorial will guide you through the essentials of getting started with Lark, transforming raw text into meaningful programmatic structures. First, the absolute prerequisite: installation. Open your terminal and simply type pip install Lark. Once installed, the journey begins with defining your language's grammar. Lark leverages extended Bacchus-Naur form, EBNF, a human-readable and widely adopted standard for specifying syntax rules. Imagine you want to parse simple arithmetic expressions like 1 + 2, 3. You define rules for numbers, operators, and how they combine, clearly specifying precedence. For instance, start expr would be your entry point, followed by expr term plus dash term and term factor / factor with factor number expr. Lark handles the complex algorithms for parsing based on this grammar automatically. Next, you instantiate the Lark parser itself, providing your grammar string. For our arithmetic example, parser equals Lark, grammar _ string, start equals expr, propagate _ positions equals false. With the parser ready, you can now parse any input string that conforms to your defined grammar using tree equals parser.parse, 1 + 2, 3. The result, tree, is a hierarchical tree object, Lark's representation of the parsed input. This tree structure is incredibly powerful. Each node in the tree corresponds to a rule in your grammar or a terminal token, like number. Inspecting tree.pretty will reveal the structured breakdown of your input, showing how 1 + 2, 3 is interpreted as an expression composed of terms and factors, respecting operator precedence. However, a parse tree alone often isn't the final goal. You usually want to do something with that structure, like evaluating the arithmetic expression or converting it into a more convenient Python object. This is where Lark's transformer(s) come into play. A transformer is a class where methods correspond to your grammar rules. When you call transformer.transform tree, Lark traverses the tree, calling the appropriate method for each node. For our arithmetic example, you could define methods like number, item return int, item, and add a, b return a + b, effectively evaluating the expression. Lark handles the recursion and argument passing, making tree traversal and manipulation surprisingly straightforward. This mechanism allows you to convert the generic parse tree into specific domain objects, abstract syntax trees, ASTs, or even direct results like the value of an arithmetic expression. Lark's elegance lies in its ability to abstract away the complexities of lexical analysis and syntax parsing, providing a high-level, declarative way to define languages. Its EBNF support makes grammars clear, its error reporting is helpful, and the transformer pattern provides a clean way to process parse data. Whether you're building a mini-language, validating structured input, or just need to parse a custom file format, Lark is an indispensable tool in your Python toolkit. Thank you for watching, and please consider subscribing for more Python tutorials.